How will the history of our universe end? And most importantly, when will it be? Is all this not eternal? The universe is almost 14 billion years old, and it would seem that it can safely continue to exist forever. But actually, no. Everything comes to an end. Everything. Even stars and galaxies. Everything tends towards a state of minimal energy. And because of this, 3 possible apocalypses are waiting for us. To understand what will happen to us, we must first know what decides the fate of the universe. Meet dark energy. In 1998, scientists observed a new supernova, a Type 1a supernova, what's known as a standard candle in cosmology, used to measure great distances. The brightness of the explosion of such stars is almost always the same. So, measuring the brightness of the explosion as seen from Earth, one can determine the distance to the place where it occurred. There's another way to determine huge distances, using something called the redshift method. The details are a little hard to explain, but briefly, as the light from a distant object flies towards the Earth, it gradually shifts to the red part of the spectrum. So, measuring the redness of light from distant galaxies, one can determine how far they are from us. According to the first method, the new supernova was 7 billion light years away, and according to the second method, 12 billion light years away. The only way to explain where the additional 5 billion years came from was to assume that our universe is expanding, and that expansion is constantly accelerating. This is a big deal. It is precisely dark energy that is theorized to be responsible for the expansion of the universe. In a way, it's almost like anti-gravity, inconsequential here on our Earth, and even within our galaxy, but exceeding the power of gravity at the mega distances between clusters of galaxies. This means that unless a faster-than-light mode of travel is invented, we will never be able to visit most of the universe. We'll be limited to our local group of galaxies, which includes the Milky Way, the Andromeda Galaxy, and several tens of dwarf galaxies such as the Magellanic Clouds. Even if you sat down right now, in a ship that could travel at close to the speed of light, you could never leave the local group. All the other galaxies and clusters will fly away from you faster than you can approach them. It's believed that dark energy is evenly distributed throughout all of the universe and most likely always had, has, and always will have a constant density. The density of dark energy can have 3 values: less than -1, greater than -1, and equal to -1. The first theory, the Big Rip. Let's analyze the first case. If the density of dark energy is less than -1, then the universe will end in something called the Big Rip. According to modern observations, the lowest possible value of the density of dark energy is -1.08. Everything in our universe will end, in this case, in a minimum of 80 billion years. All observable objects, except for our galaxies, the local group, will fly away from us, all the while accelerating, until the speed of this expansion itself reaches the speed of light, after which we won't be able to see anything beyond our cluster. The first most distant groups of galaxies will begin to disappear in about 10 billion years. The nearest will cease to be visible after about 60 billion years. 200 million years before the rip, our local group will begin to disintegrate. As a side note, at that time there will be a new, larger combo galaxy here, the result of the collision and merger of our Milky Way and Andromeda, and about a dozen other small galaxies that manage not to get merged, but are in orbit around it. 60 million years before the Big Rip, this new galaxy, which scientists propose calling Melomedes, will begin to lose stars from its periphery and will completely disintegrate in another 40 million years. Solar systems will begin to disintegrate a few months before the end. The remnants of our solar system will stop spinning around the corpse of the sun, now a white dwarf, and will fly into the rapidly expanding universe about 3 months before the end. The planets will be broken about an hour before the end, and the basis of our world, the very atoms it consists of, will be destroyed in a nanosecond just before the final tear. Only non-composite particle points, elementary particles such as electrons, quarks, and gluons, will remain from the wild and unimaginable diversity of what was once the universe. They will never collide again and will form nothing new. Each elementary particle will move away from every other one faster than the speed of light. Nothing more will happen. Never. Ever. The second theory, the Big Crunch. If the density of dark energy is more than -1, then tens of billions of years from now, the force of gravity will win, and the history of the universe will end with a little more fun. By the way, this theory is the least likely, but we still don't fully understand how dark energy works, so the Big Crunch still remains possible. Due to the fact that the properties of dark energy are not fully known, it's impossible to name even approximately how much time we have left in this scenario for the end of the universe. You can only describe the events that come before the end, without being exactly tied to time. First of all, it should be noted that not only all of the galaxies, superclusters, and all that other fun stuff will converge, but that the size of the universe itself will shrink. When it decreases 5 times from its current state to a diameter of 20 billion light years, all the aggregate star stuff will merge into one supercluster, with the galaxies being the constituent elements of the cluster. They will remain. They will still spin around each other and collide, but they will not be separated by overwhelming distances. Unlike the previous version of the development of the universe, in this one, you can reach any place, anywhere you want to go, if moving at near light speed. When the universe shrinks to 1 billion light years across, the superclusters merge into one giant galaxy, and the cosmic microwave background temperature will reach 32 degrees Fahrenheit. That's 0 degrees Celsius, and all the stony planets in the universe will be suitable for life if there's water on them. So, let the universe shrink rapidly, and the CMB temperature will create a comfortable warmth, and life can be born. But, alas, the background temperature will continue to warm up for millions and even billions of years. The temperature will grow higher. Space will become smaller and smaller, until finally, even atoms will split and disintegrate. Everything will return to a state like that before the Big Bang. In the end, the universe will finally consist of one micro-singular mass of infinite temperature and density. What happens next cannot be predicted. Modern physical laws don't apply in such a place, but it is possible that the Big Bang will happen again, creating a new universe. The third theory, heat death. If the density of dark energy is precisely 1, the universe will slowly but infinitely expand at a constant rate. Clusters of galaxies will forever fly apart, but objects within the clusters will forever remain gravitationally bound. After a few tens of billions of years, the galaxies will exhaust their supplies of dust and gas from which stars form. The main sources of light will be long-lived red dwarfs, small, dull stars, often only 1/10 as light as our sun. After about 10 trillion years, the last red dwarfs will cease to glow and turn into black dwarfs. The universe will plunge into darkness, only here and there illuminated by the remnants of its former greatness, even dimmer neutron stars and white dwarfs. Gradually, all matter will be absorbed by black holes, which will grow to unimaginable sizes for trillions of years. Hundreds of trillions and trillions of years will pass until the black holes evaporate due to Hawking radiation. This happens because photons, with a very low probability, can escape beyond the event horizon of a black hole. Over a long enough period of time, black holes evaporate, leaving only photons and quarks and electrons in the universe. Occasionally, the electrons and positrons will combine into positronium atoms and then immediately annihilate. Thermal death has come. If this all sounds a little frightening, don't worry. At present, we have an entire universe full of bright stars and, I hope, worlds fit for life. No matter what happens, billions or trillions of years from now, we should rejoice that we are lucky to live now, at this perfect time when we can learn how our universe was born and how it will end. We can observe the universe in all its grandiose beauty right here, right now, and it is wonderful. If you have any ideas for future episodes, please leave them in the comments below. The author of the best idea will have their name presented in the video.